good morning, good evening, depending upon wherever you are in the world. Okay, so let's get started. For those of you who have been doing my sessions, you know how I go about my sessions. Usually, I have this cheat sheet over here. Basically, I use to run by the content, which I'm going to be telling you about in some time, and then I also use this as a sheet to write my definitions or the concept that I'll be explaining to you. And what I do is one by one I keep completing the content and keep marking it over here. So just like now, for example, Richard has completed my introduction, so I'll just come here and say done, and I'll keep marking other things also like this as done. So that's what it is. That is how I'm going to be going about this session. So that's one part. Second part is that let me just quickly run you through the structure of this presentation, how I'm going to be going about it. Basically, since this is about 3 steps to your dream big data role, I'm going to be telling you about 3 steps as to what all technologies, what all frameworks, what all software you should invest your time in. So that you can land up ultimately into that kind of job or role. So one of the first step, if you see over here, is about some big data technology called as Hadoop. The second step is about a little bit about Spark, because that's something which has picked up quite big time in the last I would say an year or so. And the third is about a bit about statistics and data science. I'm going to be telling you about that. So that's what the structure of my presentation. I usually tell the structure as well, so that you have an idea as to where we are starting and where we'll be ending up in these I would say, give me 1 second. In next 45 minutes or so. Anyways, so that's where we are. Let's get started with that context being said. Before everything else, let's first understand what is big data, formal definition to big data. The other day, one gentleman, I think it was one of my attendees in one of my batches, was asking me, you say that big data is huge, you say big data is big. How big is big? When does the game begins? Can you tell me how big is big? So I asked him, tell me what is the hard disk size of the computer that you use? He said, I have a laptop which has a 1 terabyte of hard disk, and I've got a desktop which has got 4 terabyte of hard disk. I said, amazing. Any data which your laptop or your desktop cannot store conveniently, comfortably, that data is big data. Any data which your machines, which your individual machine, which your machines, single machine that you work upon are not able to store it. Forget about processing it. The first question that comes in is to storing it. Right? Any data that your individual machine cannot comfortably store it is big data. So I'm talking about size, I'm talking about volume, I'm talking about the sheer humongous size of the data, where storage itself becomes a challenge. And that challenge is welcomed by everyone, because everyone knows that if this is the challenge which they can overcome, right, and analyze this data, process this data, so that they can get some meaningful insight out of it, they can have advantages over their competitors. Right? Advantages over their competitors. So storage is a challenge. Right? Before I tell you about these challenges, let me just formally tell you the definition of big data as I've written over here for you. According to American IT research advisory firm Gartner, big data is high volume, high velocity, and high variety information asset. High volume, right? Huge data, humongous data. High velocity, data coming at huge speed. Like, something like if you would have seen your log servers, how they get started. They get started they get started and they start generating logs at breathtaking speed. Suppose somebody asks you to analyze that log. Right? Log aggregation, that is a field of study on its own. That is high velocity. Suppose a server like Twitter or a server like Facebook or application like Facebook, application like Twitter, application like Flipkart has decided to stream the data. That is high velocity data. That is data which is like constantly coming. You have a need to capture that data and then store it so that you can analyze it. Right, so high velocity, and then high variety information. Right, variety. It is not only text, it could be image, it could be binary, it could be audio, it could be video, you name it. Right, it could be of different forms. Right, it is that kind of information asset that demands cost effective. Right, till now we have been using traditional systems which are very costly. Think about those IBM servers and those Sun Solaris servers running into lakhs and crores of rupees. Right? See, it demands a cost-effective, innovative form of information processing that enable enhanced insights so that you can take decisions which becomes game changer for your business. Right? Which becomes game changer for your business. Right? And then you create processes using big data technologies which basically automates everything. And there are these various different components which are present for each and every word that I have emboldened here for you. For process of automation, there is a big data framework called as Apache Uzi, which automates your processing of data. Right? For high volume data storage, there's something called as HDFS, which we'll know in some time. For processing, we've got something called as MapReduce, which we'll know in some time. Right? Process automation. So this is the quick introduction to big data, I would say. Challenges with respect to big data. Storage is one thing that I have spoken about, right? Isn't it? Storage is a problem. Storage is a challenge, right? The another problem is obviously you want to do business analytics, right? The other problem is processing that information. How to process that information? That itself is also a challenge. Itself is also a challenge. Let's see if we have any technology available which basically meets these challenges, provides solution to these challenges. Do we have it or do we not? Let's go and find out. Let's go and find out this definition of this software called as Hadoop. Right? Hadoop definition. Quickly. Apache Hadoop is an open source framework meant to provide an automated distributed computing environment. It is an open source framework, right? Open source frameworks, open source softwares are the softwares which have certain characteristics. Number one, they are free of cost. Number two, they are they have a huge community base. Right? Where you just come across a problem, somebody will be there to solve it. And framework are those mundane, repetitive activities which are actually not business logic, not business analytics, but it is something that you anyway have to do. Something like security framework, logging framework, transaction framework, right? If you talk about technology, database connection framework like JDBC, web services framework, many of them. So it's that kind of open source framework. What is it? Provides an automated distributed computing environment. Right? So if you work on distributed computing, you would know that working in distributed computing manually is a pain. One of the machine going down, right? The other machine will have to be brought into rotation. It's basically a very cumbersome, time-taking and error-prone process. What Hadoop says is that I will provide the solution. I will provide an automated distributed computing environment where if your machines are going down, I will make sure that I will replace the bad machine with a good machine. I will do that. Right? Also, it provides solution to these above two problems by way of these two things. Number one is Hadoop distributed file system. It gives something called as HDFS, Hadoop distributed file system. Right? Which is an amazing storage mechanism. And it provides something called as MapReduce, which is a processing framework. Right? So storage was a challenge met by Hadoop using HDFS. MapReduce processing was a challenge met by Hadoop using MapReduce as a solution. So two Once two challenges came in front of you because of big data, storage and processing. Those two challenges are solved, are met by a technology called as Hadoop, Apache Hadoop. Now, that's why they say that Apache Hadoop is something which is married to big data. It shines when you throw big data at it. It shines. And as you know, the data around us is becoming huge and huge. I mean, if I ask all of you all, you would have definitely, each one of you would possess at least a 500, terabyte of hard disk. 500 GB of hard disk to save your data. Right, and you would have your, your movies and your resumes and your softwares and whatnot, your projects and whatnot. That is data. Like in individual capacity, imagine how much data the organizations and corporates would be generating. So this is what it is. Challenges with respect to big data. Quickly, Apache Hadoop solution. What I'll do is, with this brief definition of Hadoop, what I'm going to do is that I'm going to run one sample program for you to tell you how the program looks like, how the program runs like. So just come here. I'll show you the software. This is the software running on my local machine, right? And you can see all these software daemons running. Right? When you join my class, I kind of in detail, in depth go through these concepts on what are daemons and what are what is what over here. So these are all the daemons. These are all the software daemons which run for you in your which are running for me in my local. These are some of the the commands, what you call HDFS commands. If I do Hadoop FSLS, it's basically is going to show me the output of HDFS. What I can do is that I can say Hadoop rm-r/output. It will delete my output folder. Right. I'll quickly go and do a sample job run for you. Right. That's how the job looks like. Right. That's how the job looks like. So the job will run, the mappers will run, the reducers will run, and it will basically give me. This is basically a canonical word count program that I'm trying to kind of run over here for you. So while the job is running, I would like to see the mapper has started running 0%. The reduce will run 0%, and then mapper will become 100%, and then reduce will become 100%, and so on and so forth. It will keep going on like that. Right, so this is a canonical word count program that we have run. Hadoop sample run. You can run the same program on a big data file also. So I have, if I go to this, I can see Hadoop FSLS. I can see over here that there's a 1 GB file. I can run my same program on a 1 GB file as well. Right. So what I'll say is that I'll just kind of delete the output again here, and then while running the program, I'll just say instead of test.txt, I'll say 5.txt. What do you say? And this program will run. It will keep running on and on and on and on. So the point over here is that after running running this program for you, let the program run. Let me come back to the content here. The point over here is that step number 1, in order for you to move towards your, that big data dream job, you have to learn Hadoop. Right? You have to learn Hadoop. You have to learn Hadoop. There is no getting away from that. And Hadoop, by the way, is a software which is made in Java. So you will have to have some kind of Java background as well. When you join, our course, we basically give you some Java modules along with, I have some Java slides prepared, with its code up and running for you to kind of practice and become proficient in it. Right. So this is the job running. Like it'll take some 2-3 minutes to run. So that is the first thing that you do. Now in Hadoop, there are so many things which are there. Hadoop itself, HDFS, which is part of Hadoop, job runs, which we have done just now, and then NoSQL databases. Right? Hadoop runs in a batch-oriented manner. Hadoop runs in a batch-oriented manner. It cannot be plugged behind your RDBMSs. because it's batch oriented. But if somebody wants to access big data on a real-time basis, that is where NoSQL databases come in. And NoSQL databases there are various categories of it. There is a NoSQL database which is based on Google white paper called as Google Big Table white paper. Right, it is called as Edge. That category is called as NoSQL database basis based on Big Table white paper. So HBase and Cassandra are those databases. Right, MongoDB, you would have definitely heard about it. You should learn MongoDB as well. There's very excellent courses available on the web which can, by the way, help you understand it. So that is the first thing that you should do. Get this job done. The second thing that you should do, my friend, is that you should basically learn Spark. Now, before telling you about Spark, let me just give you a bit of background as to why Spark and why Spark has come into the picture. Now, if you could slight idea about Hadoop, you would know that in Hadoop there is a process called as shuffle and sort. Mappers do a dump on the individual machine on which the mappers are running, and then from there shuffle and sort mechanism picks up and then delivers it to the machine on which the reducer is running. So there's a whole lot of data getting dumped on the machines on which the mappers are running, and then reducer processing it. Now that actually writing something on the machine is basically a performance intensive exercise, right? MapReduce has been doing very well in the last 3-4 years. It probably has the penetration also right now in the industry where people are using it quite prolifically. But then there is a need for faster analytics where these processing units don't have to dump data on the individual machines. Right? They don't have to dump data on the machines on which they are running. These jobs can do in-memory computations and then basically do the final output on any storage mechanism, HDFS or any storage mechanism of your choice. Right? So the need for real-time faster analytics, again in batch-oriented mode, is where Spark comes into the picture. Right? So that is the step 2 that I would like to tell you, my friends. Right? That is the step 2 that I would like to tell you. Learn Spark. Because it is going to keep you relevant for at least next 2-3 years, I would say. Right? Learn Spark. Now, Spark, with that background, what is the formal definition of Spark? Let's go ahead and understand it. Let's come to the next page. Apache, again, it's Apache product. It's a fast and general purpose cluster computing system. It is order of magnitude faster than MapReduce. In fact, in latest versions of Hadoop, especially of commercial softwares, MapReduce is getting slowly replaced by Spark. Right? So it is a fast, let me embolden it, and provides. So it is a cluster computing platform just like Hadoop and MapReduce, but it is faster. Right? It provides high-level APIs in Java, Scala, Python, and R. It provides you not 1 but 4 interfaces. One of them we'll see. Right? Java, Scala, Python, and R. You can use any that you are comfortable with. And an optimized engine that supports general execution graphs. You would have heard about this term called as DAGs, direct acyclical graphs. So what it does is that when you put the data inside Spark, it basically creates a DAGs, right, of the jobs, of the tasks in the cluster, and then run them one by one. Right, run them one by one, and without dumping an intermediate data onto the disk on which the task is running. Right, onto the disk on which the task is running. It's supposed to rich. So apart from it having those core, core API, core API libraries, it also has got some rich high-level tools to give you specialized frameworks like Spark SQL, where you can deal with big data in a SQL fashion, right? mlib for machine learning, right? Streaming for streaming data, like I was telling you about log processing, and graphics for processing of data which is getting generated from, let's say, graph based data, like data that you get from social networking. Right. So that kind of thing. So that is what you can do. You can basically learn Spark. That is the formal definition of Spark right over here for you. let me just show you Spark and how it looks like. I'll kind of quickly tell you. So this is core Spark over here, Spark code in between. If on top you go, you can see all these specialized interfaces, these rich tools like Spark SQL, Spark Streaming, mlib, graphics, and below over here you can see these resource managers. Now, if you know about Hadoop, you would know that Hadoop has got a resource manager. Here you've got three options of resource manager. Yarn, which is Hadoop's resource manager, Mesos, which is another Apache very popular resource manager, and Spark's own resource manager called as standalone scheduler. Give me 1 minute, I'll just have some water. Spark's own scheduler called as standalone scheduler, right? A standalone scheduler. So this is what it is. Now, this is done. Yeah, how Spark works. I'll just quickly give you an idea, and at that time I think it becomes prudent. It becomes prudent for me to also show you something very interesting, and that is about my about my blog. So I usually write this blog. I keep updating it as well. If you go to this section on my blog, let me just show it to you. Where is it? Similarities and differences between there you are. Similarities and differences between Hadoop and Spark architectures. Right. Let me kind of tell you about this. So I would also share this blog link with all of you all on my chat window so that everyone has it. And then basically I'll just go go one by one. Yeah. So as you would know, in Hadoop, you've got something called as something called as driver class. Something called as driver class. So in Spark, you also have got a driver class, but it is context. Right? It is called a Spark context, and it looks like this over here. Let me show this to you in a graphic also, while I'm explaining this from my blog. Right? So you've got a Spark context over here. Right. One difference between Spark and MapReduce and Hadoop is that Spark gives you shells. As I was mentioning you in the definition, it gives you shells in Scala, it gives you shells in Python. MapReduce does not give you a shell. When you have a shell, it becomes easier for you to proof test your programs. Right. So this is what it is. So this is a Spark context over here. In between, you've got something called as give me 1 second. You've got something called as a cluster manager, right? And there are three flavors of cluster manager. You've got you've got Yarn, you've got Mesos, and you've got Spark standalone. And by the way, let me see. Yeah, my job is over. Woohoo! Yes. Yeah, my job is over on a 1 GB file. So yes, correct. Claps. Okay. So anyways, so that's what it is. So yeah, so there you are. So you've got cluster manager, and then just like Spark, just like MapReduce. In MapReduce, you've got master nodes and your slave nodes. Here you've got something called as worker nodes. Right, so you can see worker nodes over here, and MapReduce has got something called as containers. Here you've got the same things known as executors. That is the runtime which provides you the JVM. Right, and MapReduce has got mappers and reducers. Here you've got something called as task, which can be a mapper, which can be a reducer. Right, so that's how Spark works. If you see my blog, the last line it says that how does it work. Now this way Spark works is through Spark context via underlying cluster manager, whichever cluster manager is there of your choice. You get hold of executor processes for Spark jobs to run. So you submit the job from here, and you get hold of all these executor processes. And then these executor processes gets in touch with HDFS to get the block of data, and then run these tasks, which could be mappers or reducers in memory without having the need to do the dump on the machine on which these tasks is running. The dump is done in the end, and when this job returns, you get the you have the option of doing the dump either on the HDFS or giving the value back to the Spark context, you yourself, to you yourself. Right. So this is what. So what I would urge you guys is to kind of go through this post in detail. Whatever I've just explained to you right now is what is given in this blog. Right. So going back to this here, I think this is also we've done. Now Spark has got something called as RDDs. Concept called as RDDs. Right. And RDD in Spark is simply an immutable distributed collection of objects. Right. So RDD basically represents data and computation. In Hadoop, data is HDFS, computation is MapReduce. In Spark, RDD is both data as well as computation. Right. There's a common abstraction. Right. And you have when you're creating the RDDs, you have the options of defining how many blocks. Here it is called as partitions to divide your data into. Right. And then your cluster manager decides which worker node your partitions will go and store the data and do the computations. Right. So Spark and RDD in Spark is simply an immutable distributed collection of objects. Each RDD is split into multiple partitions depending upon how you have defined your partitions. Okay, so you have the options of defining your partitions on your own, and which may be computed on different nodes because your underlying cluster manager is going to decide for you where on your worker nodes these tasks will get executed. Right? RDDs can be written in any language: Python, Java, Scala, and R, and your own RDDs as well. There are two types of RDDs: transformations and actions. Transformation basically load the data and create new loaded RDDs from the previous RDDs. Actions basically give you back the results. So action is the MapReduce part. Transformation is the HDFS part. That's how you can make the analogy, my friends. Right. So why don't we do this? Why don't we go into one of the shells and run some programs? So I've done this quickly and this quickly and this also quickly. Why don't we go ahead and run some programs? So there you are. Let me go ahead and start a Spark shell for you. Right. Let us start a Spark shell. It'll take a while, to get started. In the meantime, let it get started. And you can, if you have a Mac machine, you can do the installation. And by the way, doing the installation of Spark is also there on my blog. Doing the instructions, the instructions for doing the Hadoop installation are also there on my blog. I urge you guys to go through them and kind of use it for your own for your own convenience and benefit. Right. So that's there. Now I'm just waiting for the shell to get started. Some of the interesting posts in my blog is I'll tell you, one of the most popular posts is single node installation and Hadoop single node installation. Another popular post is Hadoop multi-node installation. So a multi-node installation in Hadoop looks like this. I've done a multi-node installation over here. I can run it. I won't be able to do it now because of the scarcity of time, but you can definitely run it. I usually do it in my sessions. So if you pick up something like this, so if I come here in HDFS, what you can see is in my normal terminal, what you can see is if I say ls -l, I can see a file here, test. Right, this is a wonderful session, which it is, isn't it? So I can come here and load the same file, from here. I can say, Kadak, text file. It will load the data. So basically, this text file operation is creating an RDD. Right, I could have given the option as to how in multiple partitions or blocks it can, divide. And then over this, I can run multiple actions. So something like, count, right? Count is going to give me number of lines. It has got only one line, so it will give me one line. Something like a first, basically give you the, first line. This is a multiple session, right? Something like this. Now, let's do one thing. let's try and run our word count program over here in Spark. Why don't we do that? Now, in order for me to do that, I have to first of all, tell you a couple of things in Spark itself. Right. The first thing that I'm going to tell you is, is a transformation called as flat map. The details of it is written in in this blog. I urge you guys to go through it. There's something called as flat map, which basically does the operation of string tokenizer. If you know Java, right? So basically, create the words and take a string of line and then divide them into individual words and then flat out all the output. We'll see an example of it. Let's say I have got this as an input, isn't it? Let's say I've got this as an input. There you are, right? There's something called as parallelize method where you can give your sample data. In the previous example, I loaded the data from the local host. Right here, I'm loading the data from a parallelize method, where you can give sample data. This is good for practice, not for production or development. I say enter. It is creating an RDD for me over here, and then I will apply a flat map transformation over here. Now, the characteristic of this flat map transformation is that it basically takes function as a parameter. Right? If you know Scala, if you've got some idea about Scala, you know that Scala is a language which improves upon Java, and Scala is the world where objectivism, where object-oriented programming meets functional programming. This is an example for you on a Scala shell. Right? What I'm saying is that in flat map, just tokenize words by space. I'll enter it and I'll say word dot y dot collect. Collect is a action over here. When I say this, it basically is going to give me these words. Simple, very simple. Let's quickly we'll see another transformation over here called as map. Map basically does the same thing what a mapper does in your MapReduce. Right. So again, we'll load some data. Yes, again we'll go ahead and load some data and do a mapping for it. What do you say? Right, so I'll say paste, I'll say parallels. RDD got created, I'll use map on top of it. I'll say it basically does as something called a segregation. When you do when I take my sessions, I usually say that MapReduce is an element of three parts: segregation, assimilation, aggregation. Segregation is mapper, assimilation is shuffle and sort, aggregation is reducer. So what map is doing over here is that it is doing segregation. It is segregating these individual words and marking them as one as the function is given. Let's see the output of it with collect action. Yeah, everything is marked as one, which is fine, which is great, which is what we wanted, isn't it? Right. There is a third action called as count by key. It basically does a count of the key. Right. So if you see this over here, example is repeated, but it has not been aggregated. If you on top of it use something called as count by key, what you will see is that kadak, your similar words will get summed up. Right. So why don't we do this? Why don't we combine these transformations and actions into one and find out word count of our text file? Why don't we do that? Why don't we do that? Why don't we do that? Let's do that. Let's declare our text file again. Right. And let's chain all these lines over here. Yeah, flat map, space, map, word by one, and count by key. Correct. Right. So you've got is as one, this is one, wonderful as three, because three was repeating three times, and then you've got session. So that's how you can write word count in Spark. Right. That's how you can write word count in Spark. Now. So I hope you guys got an idea about how important and essential it is for you to learn Spark and make the most of it. Right. And the third part, and the third step, and the last step is that is I would say data science and statistics. I'm sure you would have, like, 10th and your matriculation and intermediate, and if those of you who've done majors in statistics and maths, you would have definitely come across lots and lots of bars and graphs. And if you work in Excel, you come across things like the bar charts and histograms and plots and all those kind of things. These have become so essential, so useful, so mandatory, so important that I cannot pay more emphasis on that. Right? Statistics at the very elementary level, starting from a very, what is the mean, what is mode, what is median, what are measures of central tendency, what are measures of dispersions, what is p-value. Right? I can talk about all this because I've done my majors in statistics, but it's not difficult, I tell you. It's not difficult. Statistics is one thing which becomes basically helps you visualizing the data. Processing and doing business analytics is one, but then showing it to your end business, to your end user in a nice jazzy visual representation is a different ball game altogether. And it's a circle if you think about it. Right? If you really want to think about it, it's a circle. The game starts at the data science level, where your data scientists are going to be, really, churning the data, finding out those, areas where they can, really mine through the areas which will look potentially, advantageous to explore, and then going to the business and telling the business that this is the area that we should look in. And then business taking a call, and then business telling the big data team to do the implementation, and then those implementation are again coming back to the statistics and data science team, which is making a nice jazzy tabular and graphical representation and presenting it to the business. That's why you need statistics and data science. Right? One of the most important languages that you would come across in statistics, and which I would highly recommend you to learn is something called as R. I don't have any scripts handy for you to show it to you, but if there is one language that I would recommend you to learn in Hadoop, for you to do well in the industry and land up with that job, is to learn R. Right? R has got this, it's basically a data visualization platform. It's very simple, very easy to use, based on statistics, and has got wonderful community support. Right? Simplilearn has got good R courses. I've done at one point of time those specializations offers by Coursera. 8 or 9 of them, which I have completed on my own, by whatever ways or means, whichever you find comfortable and get fascinated with. Learn R. Right? Learn R. There's another software called as Tableau, which is more of I would say commercial software, so I wouldn't recommend it that much. But statistics and R, for you to venture into the space of data science, is what I would recommend. Guys. And the reason why I say this is because people come to me and ask me questions, guys. And do I need to learn Hadoop? Do I need to I am an admin, so can I just get away with learning how to configure software? Do I need to learn programming languages? Do I need to think about visualization? Do I need to go to that extent? Yes, you should. I'm telling this to you from my personal experience. I have a lot of clients all across the world. I keep going to to meet these clients. When I sit with these clients, right, and they pay me whatever money that they are paying me, what they tell me is that, look, I'm paying you money. You do everything. Right? You are the developer. You are the administrator. You are the visualizer. There are 3 or 4 people in the team. You do everything. You are one-stop shop solution for me. That's why I have hired you. You do everything for me. Right? So gone are the days where people used to look for niche skills. Companies, organizations used to look for niche skills. Organizations nowadays need resources who know everything. All the areas, and they have a tendency of learning more. Right? So I usually, spend a lot of time on this in my, in my batches. I'm not going to spend more time on this, but this is, what is the message from my side? Spark, Hadoop, statistics, and data science. That is the way to go for you guys. Right. I'm done. Richard, are you there?
Yes, I am, Syed. Thank you. That was a wonderful talk. I enjoyed that immensely. We have some great questions coming in. You're welcome.
Richard, I cannot see the questions. Is something you have to enable?
It's the way they switched it. I don't have a way of letting you see the questions direct. I think because they want us to go ahead and make sure that we go through the questions and filter them out for you.
Okay. That would be great, Richard.
Yeah, so I'll look into that. I'm going to go ahead and I have a couple things I'm going to do. One, I'm going to take over your screen for just about 5 minutes while we start the QA. Mm-hmm. And set up a poll that I have going from Simplilearn. Just go ahead and launch that, and you'll see that coming up there. And then we'll go ahead and start that. We have some great questions on here that cover all kinds of different things. There's kind of a trend, and I'm going to start with a general question. We have the Hadoop file system, and of course we have Hive for the SQL and the HBase and the different setups of map and reduce. And then we have Spark that's coming in. And a lot of people are asking, hey, is Spark HBase or is Spark replacing pieces of Hadoop or MapReduce? How does Spark and Hadoop interface with each other? What's the role that Spark plays with the Hadoop file system?
Oh, okay. So I mentioned about this a bit in my presentation also. See, Hadoop has got two parts. One is HDFS and the other one is MapReduce. HDFS is a great solution for storing big data, but MapReduce has, it's as it is turning out, has certain limitations. So it does these intermediate, output on the mapper machines. Because of it, it becomes, performance inefficient. So what is, if the way I have seen the trend in the industry right now, Richard, is that slowly these commercial players in Hadoop like Cloudera, like Mapr, like Hortonworks, they are replacing only MapReduce part of Hadoop by Spark. So if you go to Cloudera website also, Richard, what you will see is that now they offer a certification in Hadoop and Spark, and they have replaced MapReduce part of Hadoop by Spark. So I would answer this in two ways. Hadoop would remain, but only from the point of view of the storage of big data, HDFS. MapReduce will slowly get phased out, and it is going to get replaced by Spark even in the raw HDFS. So I would say going forward in Hadoop, HDFS is the way to go. And then jump onto Spark and start learning Spark. That is the message from my side.
Okay, excellent. Yeah, that seems like where the market's going on there. We have a more technical question. The question is if you have this comes from. I think the screen just popped up funny. Hold on one second. I got to fix that real quick. There we go. Let me get that back up. Sorry about that. So we have a question coming in here from Leo, and he says when you have like a map and reduce, and then that puts out an answer. So you have your functions going on, and you're doing your word count, and then it wants to have another one come in there and grab that information and run it as the input for the next one. What kind of tools do you use for that?
Sorry, Richard, I didn't get the question. Can you please repeat?
Okay, so if you have two different programs going, and the first one puts out an answer, and the second one needs to process that answer. So you have two completely separate programs going. How does Hadoop handle that? What kind of tools do you use to handle that?
In Hadoop, you have to have MapReduce job chaining. There is a feature in MapReduce called as job chaining. Which is slightly roundabout way of chaining jobs, but you can configure your MapReduce jobs in such a way that one by one these jobs run one after another. So a simple answer to you would be you have to use something like job chaining. If you've been reading books, there is a book by the name Hadoop: The Definitive Guide. Chapter 11 of that book has an explanation, detailed explanation of how Hadoop job chaining can be done. See what I'm saying, Richard?
Yes. Okay, excellent. I might have to get a copy of that book.
Yeah, it's an excellent book, I tell you.
Let's see. We have from Ridham. I hope I'm saying that right. Can't we go for Python instead?
You can do that. You can do that. I just today afternoon I was talking to one of my consulting clients, and he asked me about writing MapReduce programs in Python, and I told him that there is Hadoop has got something called as a streaming API, which basically lets you write your MapReduce program in the language of your choice, and then it converts it into MapReduce. So you can write your programs in Python, and I have a lot of examples. When I take my class, I have a lot of examples in Python which I run using streaming API, and then that streaming API converts your Python programs into MapReduce, and then ultimately MapReduce get run. So to answer your question, I would say, Rhythm, you can write your programs in Python, but there's an indirect way. There's an intermediate API in between that you have to use. If you have to do it in Java, then Java you can do it directly. And otherwise, directly if you have to use Python, you can use Spark for it. So these are 2-3 options that you have available, Rhythm, I would say.
Excellent. Yeah, I'm actually come from a programming background, and so I use Spark Pi is one of the main Python interfaces, which works really good.
Yeah. Spark Pi, NumPy, so many of them.
Let's see. We still have a couple more minutes on the polling, and then I have, before I give you back your screen, let me go through some more questions here. This was a long one. Some of the question from Arshia, if I'm getting this correctly, is going in and looking at jobs. So we go into Indeed.com or whatever. They're noticing that they're asking for experience. So getting started and learning all the big data, getting their certifications. What do you suggest for people so that they can get that experience, get those initial setup?
Richard, this is my favorite question. I keep answering it all the time. So I remember I answered this last time also. So Arshia, the way I tell people is that, if you can see my screen right now, the way I tell people is that when you go for your job interview, have a multi-node cluster setup on your machine like this. I have a Hadoop multi-node cluster setup, and on this cluster have some 3 or 4 data sets ready, and have some 5 or 6 use cases ready. When you go for interviews, while you're giving the interview, you can tell your interviewer that you don't have experience, but you have got this much of hands-on experience on Hadoop and big data. Implement some use cases. Show your interviewer that these are the use cases that you have created. And then there is one more thing that you can do. You can ask that interviewer, if he has time, he can give you a use case and you can implement. You should have the skills, the knowledge, and you'll have it when you do courses like these. You'll have it. You go ahead and implement that use cases. 1 or 2 hours, that the most it is going to take, right? I'm telling you, if you follow this strategy, I'm hardly seen anybody who kind of rejects a candidate, because that is what they want. They want the person not to have there are a lot of people who have got a lot of experience, but they don't have the knowledge. Ultimately, what matters is that whether you have the skills to hit the ground running, and then whether you have the experience in the technology or not, that becomes immaterial. If you show them this kind of setup where you've got everything running up and live, executing in front of them with a couple of use cases, they cannot ignore you. Right, Richard?
Yes, that's what I'm finding. And also, not only in there, you have a blog up, and I know if you post stuff to GitHub, on my own group, because I work with small startup businesses, I've had 3 people that says, if you don't have a GitHub, I can't speak suddenly. If you don't have an account, they don't even want to see it. They want to see examples of what you're doing. They want to be able to see what you're capable of. So yes, I see that on there, and having be able to pull up the virtual machine and show them real live action what's going on.
Yeah, Richard, what you're saying is right. Your GitHub account with all the work that you've done, your blog, and this kind of setup. These are the three things which can kind of really make a selling point for you. I mean, really position you well for any kind of job. What you're saying is right, Richard.
Excellent. And then I myself am not familiar with DevOps, but I have a question on DevOps compared to, which is dependency on raw data, Splunk, and other factors. And for long term, how does that compare with the Hadoop and data science setup, the DevOps as a long-term solution?
DevOps, Richard, DevOps is more of an infrastructure management tool. So I tell you what, and I used to work a lot in this in my projects when I was like a full-time employee with multinationals. What we used to do was that for example, there is a tool called as continuous build environment. Hudson is one of the softwares. I think, what do you call, ThoughtWorks are the people behind developing it. It's more of an infrastructure management, software. So yes, let me just read that question again. Quite a similarity in creating solution. Either Hadoop data science and other ways. No, so DevOps is more of infrastructure management. DevOps is not going to do the processing for you, SN Prasad. Right? It is not going to do the processing for you. Here, it's not only about storage. It's about processing your data well, so that you can do your business analytics. DevOps is going to just kind of, do things like, so as I was saying, you've got continuous build environment. In that you can write your rules. Whoever checks in, I'm sure you would know this, whoever checks in, if he has compilation, if his code has compilation issues, a mail is going to go to all the, all the stakeholders, whoever you have configured that, there's a goof up. Right? You can do those kind of things. You can have, your pager messages or SMSs or, whatnot. So that your build continuously keeps on, depending on the frequency that you have set up, continuously keeps on building. Right. So I would say they go hand in hand, but in terms of comparison, it is chalk and cheese. It is apple and oranges. Right. DevOps tools are basically meant for a completely different purpose. That is infrastructure management. Hadoop is meant for, as you would have understood from my definition, it is meant for managing and processing big data. It's a different ballgame altogether, I would say, Richard.
Okay, now I know what DevOps is. I'll have to read a little bit more on that, and just so I have a deeper background, because I've never heard of DevOps before. I've never worked with it.
Oh, it's one crazy selling concept in the market right now, Richard.
I guess I'm out of sync on that one.
So I was working, one of my organizations where I was working as a chief learning officer last year for a couple of months. I created a course in DevOps over there. So there's softwares like Chef, Puppet, Jenkins. So continuous build environment is now called as Jenkins. And yeah, there is a whole lot of stories, so I won't bore you with that. But it's another field altogether, Richard.
Let's go. Let's see. I think we have time for one more question. Hopefully, I have time for this one. Where is the temp data when you're using the Spark stored? Where does that go? And how does that also sequence when you're doing like the linked? Linking
temp data in Spark is basically in memory. That is what makes it faster. You've got an option to have it temporarily or cache it as well, so that repeated runs of your job can also produce the data. So it's basically in memory, and it runs in such a performance efficient way on a huge cluster, which Spark will help you to kind of set up for you. It basically does not allow you to gives you the opportunity to do the dump like MapReduce does. It's in memory. All the computation is in memory. All the data is in memory. And once the computations of those chain of jobs DAG, as I was saying, direct acyclic graph is done, you get the output either on HDFS or the storage of your choice or back to your Spark context. So these worker nodes where your tasks are running, they have the data in memory. Richard.
Oops, there we go. Okay, excellent. And then we have like a minute left. So I have Anuj asked a question. What is Cloudera? And there's also, I'm going to add in Hortons and Cloudera because those two kind of go together. They're similar, but.
These are my favorite questions. I'm actually going to Chennai next week to give a presentation in a corporate on Cloudera itself. It's a 5-day training. Cloudera and Hortonworks. To basically tell you the truth, see what happens is raw Hadoop. See, Hadoop is an open source platform. If you come across any problem, challenges, in software project, it does happen. You come across a situation where you have hit a bottleneck, you hit a brick wall, and you just don't know where to go. So what there are certain what these guys have done is there are certain commercial players like Cloudera, like Hortonworks, like MapR. What they do is that they provide a specialized interface. They provide some specialized service over and above raw Hadoop. And what they also say is that for a AMC contract for whatever duration that you want, we'll provide you support as well. So if you come across a problem in setting up Cloudera or having any business problem also, we'll come and sit with you and we'll solve it for you. So to answer this in one sentence, I would say that the commercial versions of Hadoop, where you get support on a paid basis, is what is Cloudera, Hortonworks, and MapR. See what I'm saying, Richard?
Okay, so you're setting up a service so that you have a phone call away when you do run into problems.
Yeah, and the person is going to come and sit with you to solve it. That kind of service. And that's what they charge you for.
Excellent. That does wrap up our time for today. We have hit the end of the hour. If you have additional questions, we do have our forums at community.simplylearn.com, and you're also welcome to email us. I'm going to go ahead and close the session down. Thank you, Syed, for joining us today. That was wonderful.
Thank you so much, Richard, and thank you so much, all of you all, for joining the session and listening in. I wish you luck to all of you all. That would be it from my side. Yep, Richard.
Excellent. All right, thank you very much. Happy learning, and you have a good evening, morning, or afternoon.
Thank you. Bye-bye.